Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 7 from the October 2019 Statistics S1 Edexcel exam, and this is from the International A-Level paper. It says the number of cakes X bought by customers at a particular shop has probability distribution as given by this probability distribution table. What does this mean? It means this is the number of cakes that the customers buy, and this is the probability of each of those events happening. So the probability, for example, that somebody buys 4 cakes is 0.15. Now, given that EX means the expected value of X, which is actually means the mean number of cakes bought by the customers is equal to 2.5, show that A equals 0.2 and find the value of B. Okay, now, what we should know about a probability distribution table is that the sum of all the probabilities in the distribution must always equal 1. So that's how we can start with this. I know that the sum of all these probabilities is equal to 1, so I can say 0.35 plus 2a plus 0.15 plus 2b, that's going to be 0, is equal to 1. Okay, so we have 2a plus 2b plus, that's 0.5, is equal to 1. So we can simplify that as 2a plus 2b equals 1 minus 0.5, which is 0.5, which you can even simplify further. Divide both sides by 2. You have a plus b equals 0.25. So that's like one equation formed from the fact that the sum of the probability distributions is always 1. We also know something else. They gave us the expected value is 2.5. So I'll take this table and the fact that the expected value is equal to 2.5. So I know EX, the expected value of X, is equal to 2.5. What that means, expected value of X is found by multiplying the value of X by its probability for each of these and adding them together. And the sum of all of that will be the expected value of X. So we can say 1 times 0.35 plus 2a plus 3a plus 4 times 0.15 plus 5b plus 6b is equal to 2.5. Okay, so here we have 2a plus 3a, which is 5a. So you have 5a plus 5b plus 6b, which is 11b, plus that's 0.35 plus 0.6 plus 0.95, and that's equal to 2.5. So we can say 5a plus 11b is equal to 2.5 take away 0.95. Okay, that's 31 over 20, which is 1.55. Okay, so that's the second equation. So the first equation was a plus b equals 0.25, and the second equation is 5a plus 11b equals 1.55. Now they want us to find the value of a, or show that a is 0.2 and find the value of b. Now, so let's start with the first one. I want to show that a is 0.2. What I can do here for these two equations, what I can do here is, if I want to find what a is, I try and make the b's the same. So if I take this equation here and multiply it by 11, this is going to become 11a plus 11b equals, now I need to multiply this by 11, 0.25 multiplied by 11. That gives me 11 over 4, which is 2.75. And if I subtract these two equations, 11a minus 5a is 6a. That gives you 0. 2.75 minus 1.55 gives us 6 over 5, which is 1.2. So therefore a is equal to 1.2 divided by 6. So a is equal to 0.2. Now it's important that you show your steps clearly, especially when they say show that and they give you the value. So you show your steps very clearly for that. That's part 1. And part 2, we got to find what b is. Now that's pretty simple. We know a plus b is 0.25. A plus b is 0.25. So b is going to be 0.25 minus 0.2. So we can say b is equal to 0.05. 0.05. So there's the value of a, and the value of B, part 1 and part 2 of question 7a. Okay, so there's the answer for 7a. Now for 7b. 7 part B, it says calculate the variance of 4x plus 3. Now this is the probability distribution table with the values of A and B already put in there, and that's expected value of x that they told us about in question part A. So the variance of 4x plus 3, that's what this means. Now, first of all, we're going to understand is the variance of a set of data is related to how spread out the data is. And the expected value of the set of data is related to the mean of the data. All right. So I'm just going to give you an example of if this was expected value 4x plus 3 as opposed to what we got variance of 4x plus 3. I'm just going to expand a little bit just in case you get questions to do with expected value. So for example, if I take a set of data like 1, 2, 3, 4, and 5, and supposing I were to just say add something to each of those values, that's going to become 2, 3, 4, 5, and 6. What's going to happen is the mean of the data is going to increase. So the expected value of the data is going to increase. All right. So the adding something to the data changes the mean. It makes the mean increase. But adding something to each data value, okay, won't change how spread out the data is. The spread of the data is still the same. It was 4 here, it's 4 here. So adding something to each data value doesn't change the variance of the data. Variance is related to the spread of the data. So that has no effect on the variance, but it does have an effect on the mean. Multiplying, supposing I took each of these data values and doubled them. Okay, so the data values would become 2, 4, 6, 8, and 10. Now you can see that this changes the spread of the data as well as the mean of the data. So multiplying affects the spread and the mean. Adding only changes the mean. So the expected value of 4x plus 3 would basically be the same as taking the expected value, multiplying it by 4, and then adding 3. That's what that's going to be equal to. But for the variance, it's the plus 3 won't have any effect on it. What's going to happen is you're going to take the 4 and you're going to square it and you're going to multiply it by the variance of x. Okay, that will give you the same thing as the variance of 4x plus 3. And why do we square it? Because the variance is the square of the standard deviation. Okay, because the variance is the square of the standard deviation, and that's why we square each of the data values. When we're finding the variance, we have to find the mean of the squares. All right, so that's why you square. The variance is basically the square of the standard deviation. That's why you have to square this number 4. So whatever number is here, you square it and multiply it by the variance of x. Anything that's added to it, you don't add it. But for the expected value, you would take 4, multiply it by the expected value of x, and add 3, and that will give you that. So here we're not concerned about the expected value, we're concerned about the variance. So we can say that is the variance of 4x plus 3. 4x plus 3, as I just mentioned now, is going to be 4 squared times the variance of x, which is 16 times the variance of x. So we have to concentrate now on finding the variance of x. Okay, we have to concentrate now on finding the variance of x. Okay, so the variance of x is going to be basically the mean of the squares minus the square of the mean. The mean of the squares minus the square of the mean. Now the mean is 2.5, so it's going to be the mean of the squares minus 2.5 squared. We got to find EX squared now. Let's find EX squared. The mean of the squares. Now basically what that is found by simply taking the x values and squaring them. So that's 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. We don't have to worry about this because there's a 0 probability anyway. So basically EX squared is going to be this times this. So 1 times 0.35 plus 2 squared times 0.2, which is 4 times 0.2 plus 9 times 0.2 plus 16 times 0.15 plus 25 times 0.05 plus 36 times 0.05. Okay, so you're multiplying these with each other and then adding them all together. That gives you EX squared, the expected the mean of the squares basically. So that's going to give you what? Let's just put that straight in our calculator and find out what we get. So I have 0.35 plus 4 times 0.2 plus 9 times 0.2, okay, plus 16 times 0.15 plus 25, so 0.15, 25 times 0.05 plus 36 times 0.05. And that gives you 42 over 5, which is 8.4. So that's 8.4. That's EX squared. So therefore we can say the variance of X is going to be the mean of the squares, which is going to be 8.4 minus the square of the mean, which is 2.5 squared. Okay, so we're going to take 8.4 minus 2.5 squared. That gives you 2.15. 2.15 is the variance of X. So therefore we can say the variance of 4x plus 3 is going to be equal to 16 times 2.15. If you take this, you do times 16, which gives you 34.4. 34.4. So there's the answer to part B of this question, the variance of 4x plus 3. Okay, then part C, it says the cost to produce each cake is 20 cents. And the shopkeeper sells each cake for 80 cents. Find the expected profit made by the shopkeeper for a randomly selected customer buying cakes. So this is the expected number of cakes sold. All right. And this is the cost of producing each of those cakes. And this is the cost of, or this is how much they sell them for. So the profit, okay, per cake is going to be the selling price. You can think of it as the selling price, take away the cost, which is going to be 80 minus 20, which gives you 60. 80 minus 20, sorry, which is 60 cents. Okay, so the expected profit, therefore, is going to be, therefore, 60 times the expected number of cakes sold, which is 2.5. Okay, so that would be the profit, for any particular customer. So it's 60 times 2.5. Okay, so you take 60 times 2.5, which is 150. So it's 150 cents, okay, per customer. Okay, so that's the expected profit for a randomly selected customer buying cakes. That's how much you would expect to get as a profit for a customer that walks into the shop, because the mean number of cakes bought is 2.5 and the profit per cake is 60. So you expect that a customer on average would buy 2.5 cakes. Therefore, the average profit or the expected profit would be 150 cents, okay, per customer. All right, so that's the answer to question 7, part C. Now for part D. Now part D says the shopkeeper decides to run a promotion where she gives 1 free cake to all customers who buy 4 cakes or more. 4 or more cakes. During the promotion, the number of cakes taken away by a customer buying cakes has the following probability distribution. Find the expected profit made by the shopkeeper for a randomly selected customer buying cakes. Now, you can say that Y stands for now the number of cakes that the customers take away. That's what Y stands for. That's the number of cakes taken away by the customer. So that's a probability of 1 cake being taken away, 2, 3. Of course, nobody's going to take away 4 cakes, because when they buy 4 cakes, they're going to be given 5 cakes. So if they buy 4 cakes, they will take away 5 cakes. So no one's going to be taking away 4 cakes. So these are, they buy 1 cake, they will get 1 cake. They buy 2 cakes, they get 2 cakes. They buy 3 cakes, they get 3 cakes. Here they buy 4 cakes, they take away 5 cakes. So this represents how many cakes they take away, not how many cakes they pay for. So they're paying for 4 cakes, but they're getting 5 cakes. Here they're paying for 5 cakes, they're getting 6 cakes, because they give 1 free cake to all customers who buy 4 cakes or more. So now, the expected profit for each cake is 150 cents. 150 cents for one cake, right? So you could say here, let's call this the profit, okay? You could say that the profit on buying one cake is 150 cents. Okay, if they buy, no, actually the profit per one cake, that was, let me just go back there. The expected profit for one cake was 60 cents. 60 cents, sorry. 150 was the expected value. So 60 cents is the profit on one cake. So you can say the profit for one cake is 60 cents. 60 cents. Okay, so for one cake, you can say the profit would be, they buy one cake, okay, they get one cake, that's going to be, the expected profit will be 60 cents. They buy two cakes, okay, they get two cakes, so the profit's going to be 120. They buy three cakes, they get three cakes, profit's going to be 180. Okay, so expected profit, okay. They buy, the person buys four cakes, they get five cakes. So they won't take away four cakes. That's going to be zero here, right? You're going to have nobody getting four cakes. But for five cakes, they're paying for four cakes, but they're getting five cakes. Okay, they're paying for four cakes, but they're getting five cakes. So you have to think about this a bit more carefully. All right, if they're paying for four cakes and they're getting five cakes. So we can say that the profit is going to be the selling price. You're going to have 5 times 60 minus, this is for 5, okay, minus the actual cost is, they're taking 5 cakes, but they are, so they're paying for 4 cakes. So it's going to be 4 times the cost, which is 80, minus, and they're actually taking away how many cakes? 5 cakes. So it's 5 times the cost of each cake is 20. All right, so that's how much the money is coming in, and that's how much the cost of those cakes actually is. So the profit is different here. For the first three, they pay for one cake, they get one cake. The profit is 60 for each cake. There's no difference here because they're buying one cake, they're getting one cake. They're buying 2 cakes, they're getting 2 cakes. They're buying 3 cakes, they're getting 3 cakes. It's just 60 times the number of cakes. But when they buy 4 cakes, they're going to get 5 cakes. Right, so here they're paying for 4 cakes, but they're receiving 5 cakes. So the cost to the bakery or the shopkeeper is going to be 5 times 20, but that's how much money he's getting in. That's 320 minus 100, which is 220. So this is going to be, the profit here is going to be 220. Okay, and if for 6 cakes, the profit's going to be what? Well, the person is buying 5 cakes, so it's 5 times 80 is the amount of money he's paying. But he's going to get 6 cakes, which costs the shopkeeper 6 times 20, which is 120. So 5 8s are 40, so it's 400. 400 minus 120, that's going to be 280. Let me just make sure. 5 times 80 minus 6 times 20. 280, that's right. So that is the profit that you expect, or the profit that you get when you sell, when the person walks away from the shop with 6 cakes. So this Y represents not the number of cakes the person paid for, but the number of cakes that they take away when they leave the shop. So if you buy 4 cakes or more, you get 1 free. So for 1, 2, and 3, the number of cakes they buy is the number of cakes they get. Each cake has a profit of 60. That's 60, 120, 180. If the person pays for 4 cakes, they get 5 cakes. So no one's going to be walking away with 4 cakes, right? Because if they pay for 4 cakes, they get 5 cakes. So if they pay for 4 cakes, they get 5 cakes. Well, the amount of money the shopkeeper takes in is 4 times 80, because that's how much they paid. But they're going to take away 5 cakes, which costs the shopkeeper 5 times 20, because that's the cost per cake is 20. There's 5 now, so that's how you do that, and so on. That's same for 6. All right, so there's the probability distribution. It's saying find the expected profit for a randomly selected customer. So we've got to basically find what the EP is this time. So we're going to take these P values and we're going to multiply them by the probability distributions and add them together. So it's going to be 60 times 3 over 40 plus 120 times 4 over 40 plus 180 times 3 over 40 plus, well, that's going to become 0 anyway, plus 220 times 22 over 40 plus 280 times 8 over 40. And that will give you the expected profit. So that's going to give you 60 times 3 quarters. Let me just put this in the calculator as it is. But I can take out 1 over 40 from all of these. Okay, so what I'll do is I'll take 1 over 40 out. So I'll have 1 over 40. Then I'll multiply that by 6 times 60 times 3 plus 120 times 4 plus, oops, 120. Be very careful not to make silly mistakes in your calculator. 120 times 4 plus 180 times 3 plus 220 times 20, is it 22? Yeah, 22, can't read my own writing, plus 280 times 8. Okay, and that gives you 207. Okay, so that's 207 cents. We could say $2.07. That's the expected profit, okay, made by the shopkeeper for a randomly selected customer buying cakes during the promotion. So there we have the answer to question 7, part D as well. I hope that was clear. Other questions from this particular paper, October 2019, when I answer them, will be put in this place here. You'll find the link to it in that place there. Other questions from the topic of discrete random variables of S1 in this area over here. You can subscribe to my channel by clicking on this link. Don't forget to check the links in the description, which will take you to some of the documents which have my index kind of links for the playlists of different A2 as well as IGCSE papers. Thank you for watching and see you soon.